Hey, welcome back to the lecture. And from this lecture onwards, let's understand context switching. So what exactly is context switching? Now, the context switching is a process of switching out of one task and switching in of another task on the CPU to execute. In RTOS, the context switching is taken care by the scheduler. In pre-RTOS, context switching is taken care by the PendSV handler found in port.c. Alright, now let's move forward. So if the scheduler is priority based preemptive scheduler, that is true in our case, then for every RTOS tick interrupt, the scheduler will compare the priority of the running task with the priority of ready task list. If there is any ready task whose priority is higher than the running task, then context switch will occur. On pre-RTOS, you can also trigger the context switch manually, that is by using your code using task yield macro, which we have also used in our application, right? Let's go to our code, and we actually used task yield, right? So what it does, you can go and check here. So it connects you to the port yield, and here it is. So what you are doing, so you are doing what Sysdig is doing. So Sysdig also was pending the PendSV interrupt. So you are also doing the same. You are also pending the PendSV interrupt. That means you are actually triggering the context switch manually, right? Now, context switch also happens immediately whenever new task unblocks and if its priority is higher than the currently running task. So remember that whenever a task unblocks, that means when it wakes up from the sleep state, if its priority is higher than the currently executing task, then the currently executing task will be switched out immediately and the unblocked task will be made to run on the CPU. So more on this we'll explore later when we get the trace of that. Great, now let's move forward. Now, before understanding the context switching, we should understand what exactly is a state of the task, and I will cover this in the next lecture.